For this lesson, we're going to be introducing our new unit. And to do that, we're going to start with an introduction to functions. To get started, we'll begin with a couple of definitions. The first one is a relation. And a relation is a set of ordered pairs, which are values of the independent variable that are paired with values of the dependent variable. So some examples could just be a bunch of coordinates. It could be a line on a graph. It could be a parabola. There are loads and loads of examples which we'll go throughout the lesson. Next is a function, and a function is a specific type of relation. And it's a relation where each value of the independent variable corresponds with only one value of the dependent variable. And we'll go into a little more detail about that later on in the lesson. So let's start with an example. And this first example says, given a graph of a relation, how can we tell if it's a function? So again, a function is a specific type of relation. And in order to determine if a relation is a function, we use what's called the vertical line test. And the vertical line test is done by passing a vertical line through the whole curve. If it touches the curve more than once, it is not a function. So for example, let's look at relation A. I'm going to take this vertical line and I'm going to draw it on top of the curve. Now picture it sliding across the curve, and we want to see if at any point it's touching the curve more than once. Of course, this is a really thick line because I'm using a highlighter, but it's not touching 2 points of the curve. So that means that this is a function. Now for relation B, when I put my vertical line through, you'll notice that it touches the curve twice. It touches the curve once there, and it touches the curve once there. So we would say that it is not a function, and it's not a function because it failed the vertical line test. Now let's look at relation C. So for this relation, I draw my vertical line down and picture it moving across to the right. And at no point would it be touching that line more than once. Therefore, this is a function. Finally, for relation D, I draw my vertical line and we already see it's touching the curve more than once. Therefore, this is not a function because it failed the vertical line test. And that only needs to happen once. As soon as it hits the curve twice, we can confirm that it is not a function. Sometimes, though, for our relations, we're not always given a graph. So we also need to know how to look at ordered pairs and determine if the relation is a function. So, if we look at the definition of a function from above, it says that each value of the independent variable corresponds with only one value of the dependent variable. So, in other words, each x can only have one y value. So if I look at this first example here, we have the ordered pairs 1, 1, 2, 4, 5, 8, 1, 7, and -2, 5. Because our x value of 1 has a y value of 1, and it also has a y value of 7, that means it is not a function. So how we write that out is that one independent variable, which is R1, has two dependents, which are 1 and 7. So we can't have that, so we would say, therefore, this is not a function. Let's look at relation f now. So again, I look at all of my x coordinates. So 0, 3, 6, 8, 9. And because I don't have the same x coordinate twice, I know that this is a function. Now you may notice that I have the same y coordinate twice. So I do have the same y coordinate here and here. And that's okay. I can have doubles of the dependent variable. I just can't have doubles of the independent variable. And if you think about how that would graph having doubles of the independent variable, that's what would make our relation fail the vertical line test as well. So it kind of all comes full circle. Let's look at another example. So now we're going to look at a table of values. And this is very similar to when we look at our ordered pairs. So let's look at relation G. So I go through my independent and I look to see if there's any doubles. So I have -3, -2, -1, 0, 1, 2, no doubles. So I know that this is a function. Now for relation H, again, I'm going to go through my independents and I look and I have 1 here and 1 here. And if I look, they have different y values and that cannot happen. So how we write out our answer, 2 dependents for 1 independent. And that's a problem, so therefore it is not a function. So again, it's still a relation, but just not in our function category. Let's try another example here. So for example 4, if we're given an equation, how can we tell if the relation is a function? So we're not given a graph, we're not given ordered pairs, just the equation. So what we're going to do is if I plug in a value for x, any value I want, I should get only one y value. So again, if I plug in a value for x, we should only get one y value. You'll see what I mean as we go through the examples. So for relation I, we're going to plug in an x value. I'm going to do if x equals 0, just to make my life a little bit easier with the algebra. So instead of writing an x, I'm just going to write a 0. So I'll have y equals 4 times 0 plus 6. So we get y equals 6. And that's only one y value, so we're good to go. So this is a function. Next, we have y equals x squared plus 8x minus 6. So I start by subbing in a value for x. Again, I'm going to use x equals 0, just because it will make my algebra easier. So I have y equals 0 squared plus 8 times 0 minus 6, which will give me -6. And again, that's only one value, so I know this is a function. And for my last one, I have x squared plus y squared equals 25. So again, I just need to pick a value for x. I'm going to use 0 again for the same reasoning as before. So now I have 0 squared plus y squared equals 25. And then I get y squared equals 25. And to get y all by itself, we're going to square root. And that will give us y equals plus or minus 5. Now we got 2 answers for y. We have +5 and -5. And we cannot have 2 y values for a given x value. So, therefore, this is not a function because we get two y values.